So I'm going to create a method that will simply be public, and I'll make it Boolean. It will return true or false. It will check if the game is over or not yet, and if it is, it will return true or false depending. And by over, it doesn't mean that if someone won. It could be also a draw. So private Boolean, and I call it play game. I mean, it's a public because this one will be called. And all right, so we can start working on the functionality. So first, I'm going to create a few variables. Of course, I'll move this up just so we can see it better. So it's going to be integer r for the rows, and integer c for the columns, and I'm going to do some random numbers, and the random numbers will be used as a when we play against the computer. Like I said, I'll make it available to play against another player or against the computer, and the computer will simply use random numbers. There will be no algorithm or logic really. It will simply randomly select where to put its turn, like what position to take. So it's gonna be very easy to beat the computer, but I figured we can at least try that. So I will do random, and it's going to be random1 equals new random, and random, and you guessed it, it's random2 equals new random as well. So now we have random objects 1 and 2, and I'm going to find out whether I'm going to be playing against the player or the computer. And to do that, I will simply, at the beginning, I will ask the player to enter the name of the player, and if the player's name equals computer, then I'm playing against computer. Alright, so I will simply do if player name equals, first let's do when it's against the human. So if it's not equal to computer, in other words, playing against a human player. So if the player's name is not computer, then we will do console.write line and ask for the turn. So please enter where to place your symbol. This is gonna be the same for both players. They will simply be asked, okay, basically it's your turn, where do you want to move? And now that's what we're gonna use the R and C, because the user will enter two numbers, one for the row and one for the column. In other words, there's gonna be a coordinates. So if we have something like this, user will enter, let's say, 1 and 2, so that means it's 1. Well, technically it means that it would be this one, 1 and 2, so would be this position over here, right in the middle. If he enters 0, 0, it would be this position. If he enters 3, 3, it would be this position. That's why I have the R and C variables there for. So I will do integer try parse, because he has to enter a number. If he enters a string, we would get an error. So I will use the try parse to capture the input, read line, and I will trim it just to make sure that there's no spaces. And the way the syntax is out R. Basically what this means, we will try to parse the number into an integer, and if it's correct, we got the RR. If it is not, it will throw an exception. This is the syntax for try parse. The trim over here is just, I just added it there to make sure that there's no spaces between the, you know, like he enters 1 space 1 or something like that. That would be still just a string, but technically it's what he means to enter is 1 and 1. So it's gonna be 2 different lines, 1 for each number, 1 for R, 1 for C. So this is going to be actually the same thing. I'll just copy paste it, and over here we will output the C. We will again try to parse it into an integer, and if it succeeds, we get our C from the input. So this is if the player is not a computer, if it's a human. Else we are playing against the computer. So playing against computer. And over here we will use the random numbers. So we will assign R. One number for rand1 would be R, and rand2 would be C. So our R equals rand1 the next, and we will assign an integer, which would be starting from 1 to 3. So 4 not inclusive. So in other words, since 1 through 3. That's one integer. That's our R, and our C equals rand2 dot next, and again 1 to 4 or 1 through 3. Okay, so that would be the computer's turn. He would simply assign the numbers randomly. Okay, so now we have to check if, for both, for the player and the computer, we have to check if the position on the board is already used, if it's already taken. So I'm going to create a method for that, but before I do, we are going to simply do a while loop, while, and I'll call the method check board, like to check board for the, for the position. And I will create the function now. So over here I will create my and it will be a boolean. It will return if it is okay or not, if the turn was okay or not. So if boolean check board, and again it's just private because it's only called from within functions inside this particular class. And the board will accept the R and the position C. In other words, it will accept the move that either the computer or the player makes. Alright, so I will get a boolean called OK, and I will initialize it to false by default. And we know there are 3 columns and 3 rows. So if I go and do a simple conditional statement, if R is greater than 3 or C is greater than 3, so we will return false. We won't even have to bother anymore because we cannot accept more. This is particularly true for the player. The computer only takes 1 through 3. So the computer doesn't, is not going to enter a larger number than 3 or smaller than 1. But the player can, the player can enter the coordinates of 5, 5, and the board is only 3 by 3. So that's an invalid input. So that's why we don't even bother checking anything else. It's a false automatically. Wrong move. Now, if this is if the coordinates are correct or within the board, within the 3 by 3 board, now we can check if it's already taken. So if our board, and this is the let me just type the logic first and I will explain it. oops, and C minus 1 not equals 1, and board R minus 1 and C minus 1 not equals 2, then OK equals true, and we can return OK. All right, so here I am checking if the board, if the coordinates that the user entered are already taken. I'm using coordinates for R and C, but I'm using -1 with it because the board, again, let me just quickly do the board. And now to the user, this is a row 1, but to the computer, this is a row 0. Like this is coordinates 0, 0, but for the user, it actually would be 1, 1. That's why we are deducting 1. When the user enters 1, what he actually means is 0. When the user enters 2, which it would be this row to the user, the computer only takes it as 1. This is the row 0, this is the row 1, and this is the row 2. But to the user, this is the row 1, this is the row 2, and this is the row 3. The same for the columns. This is 0, 1, 2 to the computer, but 1, 2, and 3 to the user. That's why we take the user input and deduct 1 from it, because to make it work for the computer. I hope I made it clear. It's because the array is 0 based. We start from 0, but again, to the user, there is no 0 row. This is simply row 1, and this would be row 2. But again, to the when it comes to the arrays, this is 0 and this is 1. Okay, so that will check our board to make sure that it's the spot or the coordinates are not taken, and it will return true or false. It's initialized to false, so if this is not true, it will return false, like it's already taken. So when I come over here to my checkboard to loop, so it will call, with each loop it will call to check if the coordinates R and C that the user and the computer or the computer passes to the function are available. So I will do while, I will do while not. In other words, if it returns false, if it's not good, then we will over here display a message that the incorrect coordinates were entered. But we only do that for the player because, again, the computer is not going to make that mistake. We are only using numbers 1 to 3, so the computer will not pick a wrong number. It can pick a number that is already taken, but it will simply loop. So we will, after that, if it's not a computer, we will simply reassign another random number until those numbers are correct. But the user needs to be informed. So if the player name not equal computer, in the parentheses, not parentheses, the quotes, because it's a string. So if it's not a computer, in other words, it's a human player. Now if this is true, if it's a human player, we will inform the human of his mistake. So write line, you entered incorrect coordinates. Try again. All right, so this could be whether he uses outside of the board, like let's say coordinates will be 5 by 5, he would enter 5, 5, and 5, or if it's if the spot is already taken. Now the computer can, like I said, take the numbers are random, so it comes over here, and yeah, the coordinates are already taken, so it comes back over here to our else statement and reassigns another random numbers. So it will be another r equals random 1 dot next, just like before. That's all that is. We don't have to display the message for the computer. We will simply, we won't even see this really like happening. It will be so fast that it will just loop right through. So c equals next 1 and 4. But for the player over here, after we inform the user, we will reassign the values again. So I will just pass these. It's gonna be the same thing. So this again, the while loop will be until checkboard function returns true, that everything's okay. The while loop will be looping for both the player or the computer, depending on whose turn it is. So this is a similar tactic that we used to get the player's name. We would loop until the player's name is correct. So now, after the loop is finished, we know that the position that was assigned is correct. So now we can proceed. And to do that, we simply assign the symbol for a player that is whose turn it was to the board. So, but again, we have to do r minus 1 and c minus 1 because we start from 0. So, and it will, the symbol that is gonna be assigned depends on whose turn it was. Remember over here in the constructor, we have the player equals player. I told you that I'm taking an integer, either 1 or 2, 1 representing player 1 and 2 representing player 2. And player 1 will place number 1 as his symbol, and player 2 will place number 2 as his symbol. So over here, it will simply assign 1 or 2 to the appropriate position. And after the position is assigned, we can redisplay the board again, because now the board changed. So we got display board. We will simply call the function, and it will display updated board with the symbol already in it. And once it is done, we need to check if someone won or if it's a draw, in other words, if the game is over. So what I'm going to do, I'm going to create some functions, one win and one draw, which I'll call over here. So they both will return true or false. So if win, in other words, if someone won, then we will do something. Else if, I'm doing else if because it's not either win or draw, it's either win, draw, or nothing, or continue. So if, and I will call the method function draw that I will soon code, so it will do something. And so let me do the win and draw. I'll do them right here. Okay, so I'll start with the draw because it's simpler actually. So I will do, and it's going to be private again. It's accessed only from this class, not from by the user or anything like that. So private boolean draw, and oops, it's not a, I'm sorry, I missed one of the brackets. I'll declare it here. And the draw will simply see if all the everything on the board is either 1 or 2. If there's still a 0, then there's still an empty space, or so we can continue to play. But if it's not, if there's no 0 on the board, then we know all the positions are taken and if there is no winner, then it's a draw. So for integer r equals 0, r is less than 3, and r plus plus, and inside we'll do what I've been doing so far. So it's gonna be for c is less than 3, and c plus plus, and here we check if it's a 0 or not. So if, and I will do the board r and c not equals 1. I could just say if it equals 0. Now let me do it this way. This way, if we initialize it with something else other than zeros, this will still work. If I compare it to zeros and then I wanna initialize the board with, let's say, A's or C's or whatever, then this will not work anymore. So I will simply make sure that it's not 1 or 2. Those are the symbols of the players, the number 1 or the number 2. So the board are C not equal to. So if it's not 1 or 2, then return false. So it's not a draw. That's still something. If you find any element that is not 1 or 2, then yeah, it's not a draw. There's still an empty space to be taken by one of the players. All right. So otherwise, of course, we will return true. So if this loop doesn't return false, remember, if it returns false, it doesn't go any further. The function is exited immediately. But if this doesn't execute, in other words, if this is not true, then it will not return false, and it will actually return true. Okay, it is in fact draw. There really are no empty positions. Now, as for the win, I'll do it here. It's gonna be private, and it's gonna be boolean again, win. This is going to be now you have to check several conditions and combinations. So I will first check rows to make sure that the rows are not taken by one of the players. If they are, then there's a winner. If board, and this is gonna be kind of tedious to type, 0 0, so I'll type only the first two, and then I will pause it and show you the result. If player, in other words, if the board doesn't equal the symbol of the player at the coordinate 0 0, and if it equals either 1 or 2, remember over here we declared the player as an integer 1 or 2. So if it equals 1 or 2, then where am I now? Over here. Then it's taken, and it's we can check the next one next to it, which would be board 0 and 1. You know what, I will do equals, I think it's better, equals player over here too. Instead of typing it like that, I will do the equals player. So if this is true, now I have two next to each other, and now I will check if the third one is true as well. And board 0 2, so we have 0 0 0 1 0 2 dot equals player. So if this is true, basically what we have is something like this. We have 1 1 1. We have 3 in a row. We have a winner, or 2 2 2. All right. So if this is true, return true. We have a winner. and I can do another if statement. Again, remember, once it reaches this, once it returns true, it doesn't do anything else. It exits the function immediately. It doesn't come back. So if I will copy paste this, if board 1, this is the next row. So if 1 0 equals player, or 1 1, or 1 2, then again we have the second row. It's filled with by one player, and return true. And remember, the player over here, the number of the player, either 1 or 2, it is the current one. Whoever made the last turn, that's whose player's number it actually is. So that's why it's checking. Let's say if it's the first player's, it checks if it's 1, if 1 and 1. If it was the second player's turn, it checks if it's 2, 2, and 2. Okay, so I will just copy paste this. I'm not gonna pause it, I'm just gonna do it now, so you can see everything on the video. So it's 2, 2, and 2. So this is our row. Now rows are checked. Now let's check the columns, which are very similar. And what we do is 0, 0, that's where we start, but we will switch these to make it a column instead of a row. So 0, 0, 1, 0, 2, 0, and or 0, 1, or 1, 1, because that's the middle one, or 2, 1, and the last one would be 0, 2, 0, 2, 1, 1, and 2, 0. I'm sorry, and 2, 2, right? Yeah, that's correct. It's 0, 2. This is 1, 2, not 1, 1, because this is the last one. This is the middle column, so it's yeah, 1, 2, and 2, 2. Yeah, I got a little confused there. Okay, and now we have to check across. Remember, we can have across like an X. So across, and the check is we only have 2 of those. You know, let me just copy 2 of these then. There's only 2 possibilities, from left to right or right to left. So it's 0, 0, or 1, 1, or 2, 2. Yeah, and over here it would be 0, 2. These are just the coordinates. 1, 1, again it's the middle one, and this one would be 2, 0. So this one would come from the right to left. The first one is from left to right, from 0, 0 down to 2, 2, and this one is from 0, 2, which is the last position of the first row, or the row 0, and coming to the first position of the last row, which is 2, 0. All right, so this is our check. If none of this is true, then we will simply return false. No winning yet. And if there's no winning, it can be a draw. So in other words, we check the win first, then we check the draw, because the draw still can be this. You know, this doesn't check if all the positions are already taken, because they don't have to be in order for someone to win. But the draw checks if all the positions are taken. But if you check the draw first, if you check if all positions are taken, there can be still a winner. You know, with the last turn, with the last placement of the symbol, someone could win. So that's why we check the win first, and we don't care if all the positions are taken. But if this is false, if there's no winner, then we check the draw. And if that's not true, then we simply keep playing. So over here, if there is a win, we determine who actually won. If player name that equals computer, so if computer won, console dot write line, and we'll simply say computer wins. else, in other words, it's the human. If two humans playing, then the name of the player won't be computed, so this will never be true if two humans are playing. So this is basically just to make sure that we're doing everything regardless whether the player is playing against the computer or another player. So over here we'll do console dot write line and congratulations, and we will output the player name. Again, the player name is the current name, whoever made the last turn when the win condition became true. That's the player who wins. And I will output, so in other words, it will say something like congratulations, Pavel, you win. Yeah. Okay, so that's if someone won, and if someone won, we can return true. Remember, this is our function returns a boolean, because we will be checking whether someone won or not. It will check whether we should keep playing or not. So, and if it returns true, then we know that no, there's no more turns. Someone won. The same with the draw. If the draw is true, then we will return that. We will return true. Okay, the game's over. So, but if it's a draw, the console dot write line, it simply can say it's a draw. And again, it will return true. So if it's a win, it will return true. If it's a draw, it will return true. Otherwise, if these are not, neither of them is true, the whole function can simply return false. Yeah, which basically means we keep playing. So over here I will simply comment not a draw. Oops, sorry. Not a draw and not a winner. Continue game. Over here, game over. It's a draw. And over here, game over. Someone wins. All right, so let me see if I'm missing something. And yeah, let me just try to start testing it, I guess.